Hi class, Lab 9 will be an interesting and fun lab as you will learn many things related to color. I believe that all of you have watched the fireworks show on the Independence Day or other occasions to celebrate something. Some of you may wonder how the fireworks are made and how so many different colors are generated. To answer the question of color, we need to know the nature of light. It has been well known that light has dual properties of both particle and wave. That has been published by famous Albert Einstein in 1905, who won the Nobel Prize for this work. To characterize wave, we need two physical terms, frequency and amplitude, where the frequency is represented by the nu, counting the number of waves passing a certain point per second. The unit of frequency is measured in hertz, where 1 hertz equals to 1 cycle per second. The amplitude is to measure how strong the wave is. Often we do not pay much attention to the amplitude, therefore let's focus on the frequency. Another term closely related to frequency is the wavelength, lambda, which measures the distance between a point on one wave and the corresponding point on the next wave. As its name indicates that the wavelength is to measure how long a wave is. It is measured in units of length and is convenient for the type of radiation being considered. The wavelength can be as short as a nanometer, like the one of X-ray, or as large as in meters like radio, or even longer. As for the color, our eyes can detect all the waves from 410 nanometer to 740. Known as visible light. The wave with wavelengths less than 410 nanometer is known as ultraviolet, which has wavelengths from 410 to around 10 nanometer. Whereas the one with wavelengths from 740 nanometer to 1 millimeter is known as infrared. The wavelength of light can help determine color, where the visible light can be split into a spectrum stretching from red, orange, yellow, green, blue, and violet. If you like photography, you probably know more about color. Amplitude is the intensity of the radiation. For visible light, this is perceived as brightness. Therefore, if we look at a given shade of blue, it will always have the same frequency and wavelength, but it can be of different amplitude. Let's move on another question. How light is created or generated? I believe some of you have taken or are taking physics, so that this should not be a question for you. However, if you have not taken physics yet, your general chemistry lecture should tell you that the best model will be the Boyer's atomic model. Based on that and many other theories, the quantum mechanics is created. Anyway, atoms, molecules, and ions can absorb or emit energy in the form of heat, electricity, or light. During absorption, an electron is prompted from a lower energy orbital into a higher energy orbital and produce what is called an excited state. When the excited electrons comes back to the ground state, some light emits. But how? Look at it here. Those are the ground states. So when the electron on the ground state is activated, so will be jumped to the excited states, and this one is not stable, so electron will come back to the certain level of the energy level on the ground state, and the energy difference will be emitted. Color can arise from emission of light. The excited states formed from energy absorption are short-lived because they are at the higher energy level, and the electrons seek the position of the lowest potential energy. So the system will return to the ground state. In this case, electrons on the excited states will jump back to the ground state. When this event happens, the amount of energy absorbed in forming the excited states will be released, and the energy will be released in the form of either heat or light. When the energy is emitted in the form of a photon in the visible region of the electromagnetic spectrum, the material will appear to have color. According to the Boyer's atomic model, electrons orbit around the nucleus at different energy levels. We now call this energy level as orbitals. Each orbital can hold a certain number of electrons. According to the quantum mechanics, each element can be precisely described by 4 quantum numbers. They are principal quantum numbers, orbital quantum number, or orbital angular momentum quantum number, and magnetic quantum number, and spin quantum number. When the electron from a higher energy level jumps back to a lower energy level, like this one, the energy release will be the difference of energy between these two levels, according to the Planck's equation, where the h is the Planck constant, and the nu is the frequency of light. From this equation, you can tell which color of light that an atom or molecule can emit depends on the orbitals that electron transitions take place. In other words, the arrangement of electrons in an atom determines the size of the quantum jumps, and thus the energy and the colors of the collection of photons emitted, known as the emission spectra. In this way, the emission spectra serve as a fingerprint of the element to which the atoms belong. As shown in this spectra below, each element can emit a unique set of light of particular wavelengths, so that the pattern of the light naturally becomes an identity of the element, and we can detect the presence of the certain element according to this light pattern by atom absorption spectroscopy. This is a larger collection for the atom emission spectra of elements. You can see each element has a certain pattern of the light, and each light is very sharp because according to the difference about the energy level of different orbitals. This is another view for the atom emission spectra of elements on the periodic table. In this lab, we will do 2 types of experiment. One to measure the absorption spectra of certain light source, such as fluorescence light, LED, as well as neon, nitrogen, and hydrogen. And the second type of experiment is the flame test, which is easy and simply observe the color of the flame once the element source is put on the flame. Flame in blue color has higher temperature, so when the element source is put on the flame, it is activated and its electron jumps to orbital of a higher energy level. When the electrons comes back to the ground state, it emits a unique color of light depending on the energy difference. Today, we will test 6 different elements that include lithium, sodium, potassium, boron, strontium, and copper. example shown here, you will see the sodium will be yellow, and the potassium light purple, calcium will be some kind of red, strontium was this scarlet, and the barium, well, we will not test this one. Copper will show color like this.